Sanibonani, Miyaz Busiso lo. So ngizoba tutor for mathematics and physical science grade 12. So into ezokwenza will be doing previous question papers. Then kuma previous question papers, I won't do the entire question paper. Into engizowenza I will just pick few aspects ukuthi njengamanje senza ama-reaction rates ngoba sizoqala ngama-reaction rates. Usho ukuthi uma ngabe thatha iphepha la-2018 sizokwenza ama-reaction rates, iphathi nje ama-reaction rates, senze na-2019 kanjalo, na-2020 na-21 kanjalo. Sizogcina seliqeda iphepha but solokhu seliconzula ngawani. So let's get into the video. Lana-ke sizokhuluma ngama-reaction rate. That is our first topic, reaction rate. So ama-reaction rates or the rate of the reaction is affected by 5 factors. Ebe-6 kodwa yakhipha leyo kugcina i-related rate. Last year abantu ade bebhala iphepha last year bisengekho ama-related rate. So njengamanje we are left with 5 factors. Njengoba sibona laphana. Number 1 is the surface area of solids. Uma ngithi surface area of solids, ngisho ukuthi lo muntu lo uzo-affectwa umuntu oyi-solid kuphela. Ngiqonda ukuthi ngalokho, ngiqonda ukuthi ukuze ukhulume nge-surface area kuzomele umuntu abe i-solid. Awukwazi ukukhuluma nge-surface area umuntu oyi-aqueous, awukwazi futhi ukukhuluma nge-surface area umuntu oyi-gas. So uma ngabe kuzoba khona i-question ikhulume ngokuthi mhlawumbe i-surface area was increased, bese bekubuza ngomuntu oyi-gas, ukwenzakaleni kumuntu oyi-gas, the answer will always remain the same because ukuze u-affectwe i-surface area you must be a solid. So uma ngabe uyi-gas i-surface area ayikwazi uku-affect. Then number 2 sizokhuluma nge-concentration of solution. So i-concentration of solution ikwazi ukuthi i-affecte umuntu oyi-aqueous kuphela. So ukuze u-affectwe i-concentration of solution you must be an aqueous. So uma ngabe uyi-gas asikwazi ukukhuluma nge-concentration yakho. Uma ngabe uyi-solid asikwazi ukukhuluma nge-concentration yakho. Wesi uma ngabe uyi-liquid asikwazi futhi ukukhuluma nge-concentration yakho. Then number 3 sine-pressure of gases. Uma ngabe sizokhuluma nge-pressure of gases kusho ukuthi lo muntu lo izazisho lento ithi pressure of gases kusho ukuthi lo muntu lo u-affect umuntu onjani, umuntu oyi-gas kuphela. Kusho ukuthi uma ngabe sizo-increase i-gas noma when the gas is increased asikwazi ukuthi sikhulume ngomuntu oyi-solid ekubeni si-increase i-gas. So uma ngabe bezo-increase i-pressure, uma ngabe bezo-increase i-pressure bese bekubuza ngomuntu oyi-solid, the answer nakhona will always remain the same because ukuze u-affectwe ukukhushulwa kwe-pressure you must be a gas. Noma ukuze u-affectwe ukuncipha kwe-pressure you must be a gas. I-gas lile affectwa i-pressure kuphela or i-pressure i-affect umuntu oyi-gas kuphela. So once waba i-solid, once waba i-liquid, once waba i-aqueous, i-pressure ayikwazi ukuthi affect. Number 4 sizokhuluma nge-addition of a catalyst. So uma sizokhuluma nge-addition of a catalyst mfowethu awungizwe kahle. I-catalyst alikhethi ukuthi ukusiphi sona i-state. Uma ngabe sikhuluma ngama-state sikhuluma ngokuthi umuntu ngabe uyi-solid, sikhuluma ngokuthi umuntu uyi-aqueous, sikhuluma ukuthi ngabe uyi-gas. So uma ngabe sizo-add i-catalyst ile affecta wonke lama-state because umsebenzi we-catalyst uzo-speed up i-reaction. It is not part of the reaction. So alikwazi ukuthi liku-affect because umsebenzi walo alizile ukuzothinta wena kodwa lizothinta ukuthi i-reaction mayenzeke faster. That is the function of the catalyst. I-catalyst okumele ukubambe ngalo mfethu, i-catalyst uma ngabe lifaka kwi-reaction alizile ukuzo-increase the yield. Yazi mfethu, uma ngabe ngithi alizile ukuzo-increase the yield ngiqonda ukuthi alizile ukuzo-increase inzuzo. Liyafakwa nje just ukuthi alizo-speed up i-reaction. Let's say ngizokwenzela i-example. Let's say ngizopheka ubhontshisi. Kubhontshisi nginamabhodo awu-2 kabhontshisi. Then kulo bhontshisi lo ngifaka i-teaspoon. Uma bekupheka ubhontshisi kujwayele ukufaka i-teaspoon. Leli teaspoon lizo-act as a catalyst. Leli teaspoon is used to speed up the reaction. It is not part of the reaction. Anoma ngizwa kahle mfowethu. Umsebenzi waleli teaspoon lizo speed up just the reaction ukuthi i-reaction mayenzeke faster. Kodwa lona alisiyi part ye-reaction. So lokho kusho ukuthi uma ngabe initially mina ngizofaka ubhontshisi mhlambe ongaka kuleli board, ngiphinde futhi ngifake ubhontshisi mhlambe ongaka kuleli board initially, ngisho sebevuthiwe ubhontshisi bazolingana just that lona teaspoon uzovuthwa kuqala because i-teaspoon is a catalyst. uyabona kusho ukuthi ukufaka kwe-teaspoon lapha i-teaspoon alikuzile ukuzokwenza ukuthi lo bhontshisi lo ne-teaspoon awube mningi kodwa i-catalyst izokwenza ukuthi awuvule kuqala. Awukho umehluko kangako, umehluko ukuthi nje lo uzovuthwa kuqala lo ne-teaspoon bese ukuthi lo ongenalo i-teaspoon uzovuthwa muva. So that is the work of the catalyst. It is used to speed up the reaction, but it is not part of the reaction. Okay, then the last one esizoyifaka la, the last one just this. So the last one esizokhuluma ngayo, that is temperature. Bonke abantu bakwazi lokho. The last one, number 5, that is temperature. That is the 5th factor. Temperature, that is the 5th factor esizokhuluma ngayo. I-temperature nalithi ayicishe lifane ne-catalyst because i-temperature alikhethi ukuthi ukusiphi state, noma ethi ukuthi uyi-gas, noma ethi ukuthi uyi-solid, noma ethi ukuthi uyi-aqueous, noma ethi ukuthi uyi-liquid. I-temperature affecta wonke umuntu. Kanjengokuthi ngizokwenzela nje i-example encane la. Kanjengokuthi nali ibhodwe lami naliphensela. Kanje ukuthi nali ibhodwe lami la. Ebhodweni lami khona amanzi. Ebhodweni lami mhlawumbe ngifake oswidi ababili, nabo oswidi bami la. Ngifake oswidi ababili. Then mase ngenze njani? Mase ngibasa umlilo. Yini purpose yokubasa umlilo? Is to increase i-temperature. Already there is a certain temperature ekhona ebhodweni uma ngabe ngilivale ngesivalo sakhona. So there is a certain temperature ekhona lapha ebhodweni. Kodwa ngoba mina ngibasa umlilo ngizokwenza njani? Ngizo-increase i-reaction. Because when I'm adding temperature, noma when I'm increasing temperature in a reaction, I'm increasing the rate of the reaction. So uma ngabe ngi-increase ke i-temperature, uzobona isolid lincibikala, uzobona amanzi lawa eqala eshunqa, okusho ukuthi lamanzi lawa asenjani ayi-experience le temperature lesengiyi-edile. Ukuncibekala lolu sweet kusho ukuthi leli sweet nalo le experience le temperature sengiyi-edile. Uyabona ngani ukuthi i-solid le affecteka, kanti futhi ne-liquid nayo iya-affecteka lamanzi la azobela. So koyonke i-idea la ngiqonda ukuthi i-temperature affecta wonke umuntu, alikhethi ukuthi ngabe uyi-aqueous, alikhethi ukuthi ngabe uyi-solid, alikhethi futhi ukuthi ngabe uyini, ngabe uyi-gas. Those are 5 factors of the reaction rate. Number 1, that is surface area of solids. It only affects solids. Number 2, that is concentration of solution. It only affects aqueous. Number 3, that is the pressure of gases. It only affects a gas. Number 4, that is addition of a catalyst. It affects them all. Number 5 is temperature, which does what? Which affect them all. Okay. Then mase kuzoba yilento lama graph ahlupha mfethu wabheka. Mase kuzoba yilento ka-exo. Lento ka-exo no endo. Mase kuzoba yilento ka-exo no endo. Exothermic and endothermic. Exo and endo. So exothermic, igraph yakhona uzoyibona ime kanje. This is exothermic. But endothermic, igraph yakhona uzoyibona ime kanje. What is exothermic? Exothermic, it is the release of energy, or it is where energy is released. In simple terms, kukhona kuma-exam guideline explanation akhona edingakalayo, kodwa mangabe kusikhuluma nje ngo-exo, which is where energy is released, which means our enthalpy or our heat is negative. When energy is released, that means our heat is negative. Delta H is what? Delta H ngaleso sikhathi usuke usuke negative. But when you are exothermic, kusho ukuthi your delta H is what? When you are endothermic, rather, that means your delta H is what? Is positive. Your delta H is positive. Abanye bekubhala ngokuthi bethi delta H here is less than 0. That is exothermic. delta H is less than 0, that is exothermic. Bebuye bethi la delta H here, delta H is greater than 0, that is endothermic. Why bethi lo muntu lo is exothermic, or why bethi le graph le i-representa u-exothermic? It's because la kuma y-axis sine energy, la kuma y-axis sine energy. This E stands for energy. Sine energy la kuma y-axis. So into eyenzakalayo la, these are the reactants. These are the reactants and these are the products. Lo line ongaka left to represent ama reactants. Lo line ongaka right to represent ama product. Also in this side, these are the reactants, these are the products. Why kukanjalo? It's because uma ngabe ngino I2, oh rather mhlambe angibhalela ngezansi ngospace asekho la. Uma ngabe mhlambe ngino I2, plus N2, when I have I2 plus N2, these will give me these will give me 2Ni, 2Ni, and lawa ama gas, this is also a gas, this is also a gas. Khona brackets la, this is also a gas. So uma ngabe ngina labantu, they are reactants, and ba ama reactants because they are on the left side. Also nala kulama graph, umuntu on the left side uyi reactant, umuntu on the right side, which means uyini, uyi product. Then bengisayibuzile ukuthi yindaba sithi lo muntu lo, or sithi this graph represent exothermic. It's because le graph kanje ufuna ukuyidweba ibe enkulu la, le graph kanje. So le graph mangabi kanje sithe thina la sizoba ne-energy. I-energy is estimated on the y-axis, since uyibone energy lapha ingakuma y-axis. So ngithe ama-products lawa esimhlawumbe la sino 1, then sithe ama-reactants lawa esimhlawumbe la sino 3, okay. Ama-reactants, they represent H initial. Reactants, they represent H initial. Then products, they represent products, they represent H final. Products, they represent H final. So ama products, they represent H final, HF. Delta H uthini? Yonke into ewu-delta iyohlezi iyu-final minus initial. Delta H iyohlezi ewubani? Ewu-H. Into yathi delta, leyo nto isuke ithi final minus initial, HI here. What is our H final in this case? Our H final is 1. Our H initial is what? Is 3. And automatically usuyabona ukuthi la uzothola into enjani, a negative, because you get -2. That's why this graph is exothermic, because uma ngabe calculator noma when you compute delta H, you get that delta H will be what? Would be negative. And we opposite endothermic. Endothermic, your graph is like this. When sikhuluma endothermic, your graph is like this. So your graph is like this. Masikhuluma endothermic. Ubonile nto kodwa ayikho inkinga. The graph is like this when you talk about endothermic. Still laba represent in lava. I'm a product. They are similar to what? To H final. And it products they are similar to what? To H final. H final. These are the reactants. Reactants, they are similar to what? To H initially. Or they are equivalent to H initially. They are equivalent to H initially. As like initial at the 3 mhlambe. Final at the sizoba no 5. Because sibuya ngama y-axis, here we have the energy. Sibuya ngama y-axis because as I'm moving from bottom to top, I'm increasing the y values. Yabona le nto le ifana le nto ngakwi-Cartesian plane, because as I'm moving from here, from 0 going up, I'm going to the positive y values and I increasing. So that is the same thing eyenzeka la. So uma ngabe sesizo-computer noma sesizo-calculator our delta H in this scenario, when now we compute our delta H in this scenario, so that is H final, minus H initial. H initially. So our H final is what? H final, remember, those are the products. Our H final is what? It's 5 in this case. Our H final is 5 minus our H initial is 3, and automatically you see what is in the positive. That's why bet the graph where it determine noma it describe umuntu onjani, umuntu or endothermic, which is what? Which is the gaining of energy, because this one is positive. Then kuwo lama graph, sasekuwo lama graph, you must be able to know ama aspects. You must be able to know the name of this space over here, the space over here, this space, this thing. Yeah, better of it's into yami ngizama ukuthi ngilungise asinenkinga kancane nje. Okay, you must be able to know this space over here. This space over here. You must be able to know this space. This space basibiza ngani? Activation energy. Activation energy. Bajwayele ukuyirepresenta kanje. Befaka u-capital letter E, bese befaka u-small letter A. Activation energy. That is minimum energy required for the reaction to does what? To take place. Then this point here, lengathi isicoco, bayibiza nge-activated complex. Activated complex. Boyibheka ama-exam guideline. Activated complex. Activated complex. But it is the point whereby ama reactants they changes into ama product. These are the reactants. And now we want to learn. These are the reactants, these are the products. Moja check lapha kulela point. Ngikusase ama reactants yonke le ndawo kusase ama reactants, but uma ngifika la once ngamove nje ngale we-activated noma we-activation energy rather sengiyaqala sengiyakuma products. So activated complex rather, it is the point whereby the reactants they change into what? To ama products. Okay, I think amanye ama-aspects sizokhuluma. Okay, before simove siye lapho ake sikhulume futhi ngayo le mpahla le. Le mpahla has many things adinga ukuthi acaciswe. So na into enzakalayo la mfowethu, uyabona this distance here, this distance here is between ama reactants nama products. Anganoma uyibona leya distance le uyena delta H which le, that is the change in heat, not in heat, but that is the change also, or that is the change rather, that is the change in delta H, that is the change in H. So with delta H wethu lo, delta H wethu une relationship ne activation energy. Delta H has a relationship with activation energy. Na into yenzakalayo, with delta H wethu, our delta H noma our heat is inversely proportional to activation energy is inversely proportional to activation energy, which means as activation energy increases, our delta H decreases. As activation energy decreases, our delta H increases. Kwenzeka kanjani ke lokho ngifuna ukucacisa. That is the last aspect engase sizokhuluma ngayo la. Then emva kwalapho ke ngizobe sengisuka ke sengizokwenza ama previous question papers on my next video. So na into enzakalayo la. Na into enzakalayo la. Let's just do it to endothermic. Then let's take this distance here between the reactants and the product. That is our delta H. That is our delta H. This is delta H here. This is delta H here. These are the reactants. Then these are the products. So it ends la mfethu. Sithelo line lo uyini lo. Sithelo line uyi activation energy. This line or this space here is activation energy. So it ends la uma ngabe ngi-add i-catalyst. Uma ngi-add i-catalyst izohamba kanje. When I'm adding a catalyst, i-graph yami izohamba kanjeyana. So why graph yami izohamba kanjeyana is because when we add the catalyst, it lowers the activation energy. Initial activation energy amadila. Kodwa manje uma ngi-add i-catalyst yasincipha yasizala. Uyabona? So when I'm adding a catalyst, it does what? It lowers the activation energy. Na into eyenzakalayo. Sizobuya kule graph le ngizobuya kuyo manje. Let's say you are on top of the building. Sibela ku-project ke manje. You're on top of the building. Then you throw the object straight vertical upward. I-object izothi mayibuye izobuya ihambe kanje. Ngazi noma uyavuma. Mhlambe iwele here. Izobuya kodwa ihambe kanje. But uma ngabe ngiyiphosa at an angle. Uma ngabe ngiyiphosa at an angle. Izohamba kanje. Athi ngenze ngomunye ukhala ke lo. Izohamba kanje. Uma ngiyithrow at an angle. Izohamba kanje. Hayi not kanjalo. Hey. Hayi kanjalo. Kodwa kanje. Let me try this one. It's even better. Kodwa mfethu all in all into engifuna ukutshengisa yona la. Ake sithi lo kade ku delta H wethu here. This was our delta H here. Uyabona yini ukuthi as i-activation energy yami increase. As activation energy yami increase, this ball will fall here at this delta H. Uyabona lo nto le? Which means now the space between the reactants and the product, these are my reactants here. These are my reactants here. And these are my products here. No, this is not delta H, but your delta H is here. But your delta H is here. As I'm throwing this ball, these are my reactants and these are my product. This here is delta H here. This is delta H. As I'm increasing the activation energy, my delta H is like this. The one is in a form of this length. But as I'm decreasing now my activation energy, then space between the reactants and the products. Space between the reactants and the what? And the product. That is my delta H. That is my delta H. Uyabona lo nto le angeke bewele kule level eyodwa le because lo ngumphosa at an end so sazoqala hamba awela somewhere. Uyabona lo nto le but lo uzovele awe straight kule end le uzovele nje awele straight la but lo sazohamba adlule le level le azowela mhlambe kwi level kanje. Uyabona ukuthi as I'm increasing my activation energy, my delta H is less. Or my delta H decreases. But as I'm decreasing now, my activation energy, my delta H does what? Increases. As you see, which case 1, that is case 1, and that is case 2. As you see, case 1, delta H since increase activation energy, but as I'm decreasing the activation energy, it's like I'm adding a catalyst, but delta H will increase. Yona nto eyenzakalayo ke leyo uthi this thing as I'm adding a catalyst iziyafana nokulento izowela somewhere here. Then now as I'm looking manje in difference between the reactants and the product, difference between the reactants and the product, difference between the reactants and the products, say isizoba nkulu we compare to the last one. Ayichaze kahle with this graph, but ngicela ukuthi unayo kakhulu la. It is more clear when I explaining using a projectile, vertical projectile, what you call it, motion. Ngiyacabanga ukuthi abantu bazo understand what uma understandanga ngizobuya kule aspect le. Just leave your comment on this video, then I'll go back to this aspect ngifine ngiqale futhi phansi ngichaze futhi. Kodwa ngicabanga ukuthi clear with some increasing activation energy here, this ball will fall here, but there's some decreasing activation energy, this ball will fall here. Then our delta H initially was like this, and now it finally is like this. So as the activation energy is decreased, delta H seem to increase. As the activation energy is increased, delta H seem to decrease. That is the relationship here, which is denoted by this. When I'm saying delta H is inversely proportional to the what? To the activation energy. And there's a paper I think it's 2019 or 2020, a multiple choice question is a funal relationship like is a funal relationship. So I think these are the reaction, what you call it, rates, reaction rates. Bafethu ngiyabonga ukuthi nibukile lana. Ngiyacabanga ukuthi wonke umuntu useya-understanda ukuthi masikhuluma ngama-reaction rates sikhuluma ngani. Masikhuluma nje specifically reaction rates sikhuluma ngani. But okay, before I forget, kuwo lama-reaction rates kunama-graph mfowethu, kulama-reaction rates lawa sikhuluma ngawo. Kunama-graph awu-3 akalo baba lawambiza Maxwell-Boltzmann distribution curve. But Maxwell-Boltzmann waqhamuka nama-graph awu-3. Lawo ma-graph awu-3 i-graph temperature, i-graph addition of a catalyst, and the graph of a concentration. We have 3 graphs. We have only 3 graphs. Esinawo nje kuma-reaction rates nama-graph awu-3. Eyokuqala sine-graph ye-concentration. We have a graph of concentration. Number 2, sine-graph yani ye-temperature. Number 3, sine-graph yani ye-addition of a catalyst. So lama graph lawa iwona ke akwazi ukuthi abadwebe ubaba lo Maxwell-Boltzmann distribution, what you call it, curve. Ake siqale sibuke ukuqala sithe yani concentration. I-graph ethu yokuqala concentration. So i-graph concentration ayiwa. Sine-graph concentration here. La sinama number of particle. Number of particle. Number of particle. Number of particle page. Number of particle lapha. Lana sizoba ne-kinetic energy, EK, kinetic energy, EK. Here we have kinetic energy, EK. Then this graph is a graph of concentration. So into eyenzakalayo la, let's say we are given a graph of a concentration is like this, not like that. Eish. Why do you think I do it's like this initially. The graph of concentration is like this initially. Let me try the last time and see if I could draw something that is accurate. It's even better this time. Yes, let's say you have initially your C1 that is like this. Then now they say draw a graph of concentration or draw a graph when concentration is increased. So in those ways, when concentration is increased, your graph will just go like this. When concentration is increased, your graph will just go like this. No. Much. When concentration is increased, they must start on the same point. They have to start on the same point. When concentration is increased, your graph will just go like this. And this is your heart. This is your C2. When concentration is increased, your graph will go like this. But when concentration is now what? When concentration is decreased, when they say they have decreased concentration, when they say they have decreased concentration, your graph will just go like this. Like this. Kulula nje for the graph of concentration. Uma ngabe increaseiwe, izohamba ngaphezulu kwaleyo kade uyinikeziwe initially. But uma ngabe decreaseiwe, izohamba ngaphansi kwale kade uyinikeziwe initially. So this is when concentration is decreased. This is when concentration is what? This is when concentration is decreased. But this is when concentration is what? Is increased. So a graph yethu besikade sinikeziwe laphana initially sayibona ukuthi C1. C2 graph is when concentration is increased. C3 graph is when concentration is decreased. Then akasibheka isibili igraph eyani temperature. Graph of temperature. Graph of a temperature. This is the graph of temperature. I won't finish ngizobhala nje ukuthi just temp yabo mfethu uzokwazi to understand. Then the graph of temperature nala futhi kune number it's no of particle, so it's number of p. Ngiyacanga ukuthi uzo understand number of particle wona kodwa ungabhala ukuthi number of particle ngokuphelele, but mina just write no of p just to save time because time is not on my side. This is ek. This is ek. I-temperature, i-graph ye-temperature kwethu izohamba kanje. Graph of temperature will go like this. You start here and go like this. This is the graph of temperature. Then here, the graph of temperature will have the activation energy. Your EA here. Your activation energy. We are familiar with the activation energy, which is because la paper here changes and usually bazoyibhala as EA. Bazoyibhala as EA. Okay, so this is the graph T1 that we are given. This is the graph of T1 that we are given. Well, at a function a temperature, when you increase temperature, it more particle will have sufficient kinetic energy. Factors. Function of factors. When you increase temperature, more particle will have sufficient kinetic energy. I guess it's a right. Umuntu ongaka right lo muntu unayo insufficient kinetic energy. So umuntu ongaka right it have sufficient kinetic energy noma it has whatever isingisi vele ngakho ngafuna ukufundisana ngazo angisazi. So it have insufficient kinetic energy. Then umuntu ongaka left does not have It does not have. It does not have. Ngizibhala nje kanje. Umuntu ongaka left does not have sufficient kinetic energy, which means whatever umuntu ongapha ngaka left of activation energy, because lo left no right sikhuluma with respect to what? Sikhuluma ngabo with respect to what? With respect to activation energy. Sikhuluma with respect to activation energy, EA. So sisho ukuthi umuntu ongaka right ku activation energy unayo sufficient kinetic energy, but umuntu ongaka left of activation energy does not have sufficient kinetic energy. So when I'm increasing temperature, ngithi mina its function when you increase temperature, more particles will have sufficient kinetic energy. Ama particles wabonga kuma y-axis. Njama ama particle ane sufficient kinetic energy ala akulo line lo. Yabona? Akulo line lo. Akulo line lo. Mhlambe lama particle anga mhlambe awu4. Lehle same mhlambe awu4. Lama particle lawo ane sufficient kinetic energy. When I look on the right hand side, all these particles they have insufficient kinetic energy because they are on the right of activation energy. But more particles will have sufficient kinetic energy. That means line phela increase uzila. And mabu increase uyabona ukuthi mangabe sengenza ukuqondanisa kwami, sengiqondanisa la, sengenza ukuqondanisa kwami ukuthi ngempela ama particles ane sufficient kinetic energy awasekho 4 asekulayini mhlambe awu 4.5 noma mhlambe asiwu5 rather nje exactly mhlambe asiwu5 exactly. Uyabona lonto le. So more particles will have sufficient kinetic energy. More particles will have sufficient kinetic energy. Ngisuse lokho. So more particles will have sufficient kinetic energy. But akwazi ukuthi ngapha ngibe no more nangapha futhi ngiphinde ngibe no more. So uma ngabe ngino more ngapha kusho ukuthi ngapha ngizoba no less. They must start from the same point. Why ngapha ngiba no less? It's because mangithi mina more particle will have sufficient kinetic energy, then inversely ithi lento less particle will not have will not have sufficient kinetic energy. Angazi lento ngizobana ithi lento uma ngabe emaningi ama particle azoba ne kinetic energy kusho ukuthi azoba mancane ama particle angeke zebe nayo sufficient kinetic energy. Yes, ithi lento uma ngabe emaningi ama particle ane sufficient kinetic energy as I'm increasing temperature, mancaneke azosala engenayo sufficient kinetic energy, because ngithe mina ngakwa left ilaba bangenayo but ngakwa right ilaba banayo sufficient kinetic energy. So inversely when I'm decreasing now temperature, less particle will have sufficient kinetic energy. Njalo sizoqala ngakwa right mase sikwelela nga left. Mangithi less particle will have sufficient kinetic energy, ngisho ukuthi uma ngabe ngiyidecrease ke manje temperature, less particle mancane ama particle azoba ne sufficient kinetic energy mhlawumbe azobe la mancane. Uyabona ukuthi mangabe ngiqondanisa la ngempela, mangiqondanisa la ngempela mhlawumbe inamba enginayo la mhlawumbe u2. So uyabona mancane ama particle azoba ne sufficient kinetic energy when I'm decreasing temperature. Temperature is decreased when the graph is like this. When the graph is below the graph that was given, that means temperature is decreased. But since bebancane ke manje abane sufficient kinetic energy kusho ukuthi baningi ke manje abangenayo. Uyabona lonto le, bancane abanayo kodwa baningi abangenayo. Uyabona lonto le, lento ifana nokuthi uma ngabe ngizoba nabantu abawu3 njengamanje ngithi mina as I'm decreasing temperature ngizothi mina less particle will have sufficient kinetic energy. So laba bobabili laba, or rather less particle will have sufficient kinetic energy kusho ukuthi lona oyedwa uyena ozone sufficient kinetic energy. Bangakanani abangenayo sufficient kinetic energy compared to that one? Bawu2, which means baningi abane sufficient kinetic energy but uyedwa. Baningi abangenayo sufficient kinetic energy but uyedwa onayo sufficient kinetic energy. Uyayizwa lonto leyo mfowethu? Nginabantu abawu3, this 1 2 3 people, but lona as I'm decreasing temperature, this less particle will have sufficient kinetic energy. As eyedwa lo one sufficient kinetic energy, babili abangenayo, laba babili baningi phela kunalo yedwa, which means baningi abangabe zibebe nayo sufficient kinetic energy. That's why uzoyibona le graph yakho isizoqala isiyenza kanje. Isizoyenza kanje. Isizoyenza kanje. Yeah? No, ayizokwenza kanjalo. That is incorrect. It must go above, because baningi manje abangabeze bebe nayo insufficient kinetic energy. It must be like this. It must be like this. This is my T3. When temperature is decreased. This is when temperature is decreased. Baningi abangabeze bebe nayo, but mncane ozoba nayo. Uyabona le nto le? But when temperature is increased, baningi abazoba nayo sufficient kinetic energy, but bancane ke phela manje bazosala bengenayo. Uyabona? Let's make an example ngabo labantu laba. As ngi-increase sufficient kinetic energy, mhlambe sebezoba babili abanayo. Mase bebabancane abangenayo, because uzosala eyedwa ongenayo. That's why leyo graph leyo uzobona abanayo beba baningi but beba bancane abangenayo. Uyabona? Because leno T1 is the graph that we were given. So we are growing this graph with respect to the one that we were given. You see? Yes. So this is what I'm talking about here. And let me think if there is any aspect that I'm leaving. Oh, before I forget, this is the last thing. The last thing, this formula, reaction rate, this formula, reaction rate, this is the change of concentration of reactants or product per unit time, which means here I'll have the change of concentration. Change is delta divided by what? With respect to what? To time. Yabona lonto le? Leli formula mfowethu libambe la lizoba positive. If ngizocalculate i-reaction rate yomuntu oyi-product, but lizoba negative if ngizocalculate i-reaction rate yomuntu oyi-reactants. So walibona uzolisebenzisa libe positive uma ngabe sizokhuluma nge-reaction rate yomuntu oyi-product, but uzolisebenzisa libe negative uma sizokhuluma nge-reaction rate yomuntu onjani oyi-reactants. Let's say yinayo lento ka-I2. Nayo lento ka-I2. This reaction of I2 plus what? This I2 plus N2. This I2 plus N2. This I2 plus N2 will give us 2Ni. Ngiyengizabhala ama stage ukuthi ba ama gas 2Ni. So into eyenzakalayo la uma bengizocalculate i-reaction rate ka-iodine ngizofaka u-minus kuleli formula because u-I2 uyi-reactant, but uma ngizocalculate i-reaction rate ka-Ni ngizofaka u-plus. Just the formula will have a plus because why? It's because u-Ni uyini uyi-product. Ngixolele ngalo msindo loyo. Then kungenzeka ube no delta V, depending ukuthi question isuke ifuna i-reaction rate in the form of what. Ungenza ube no delta V, ungenza ube no delta M. Mhlambe mabe bezoyifuna in grams per second, ube mhlambe no delta N mabe befuna in mole per second i-reaction rate yakho. La bazoyifuna in decimeter cubed per second, noma befuna in centimeter cube per second. But lana bazoyifuna in mole per decimeter cube per second, because this is concentration. Concentration is mole per decimeter cube. This is decimeter cube or centimeter cube. This is grams or kg, and this is moles. And I think this is the end of our session for the reaction rate. I've just touched the few important aspects. Then after that, we'll look into questions pertaining reaction rates only. We'll do questions that are based on reaction rates only for now. Then when we move to chemical equilibrium, I'll firstly introduce chemical equilibrium, then we do questions based on chemical equilibrium. Ngiyabonga isikhathi sakho. See you when I see you.